Hello, cluster students. This is the next to the last video lesson. So you just got 2 this week to get out the way and you are done. So, and they're pretty short. I don't think that it's going to be too bad for you. And this is it. You don't have to do any more factoring. That's done. No more factoring. So I think this will be a little bit easier. I have tried my best to get through at least important topics that I thought was important, making sure you don't forget how to factor, and just a taste of these 2 next lessons. But other than that, this is it. The actual end of the semester is supposed to be next week, the 27th, but we aren't giving finals, so by the end of the week, it's over. You just have to do these 2 lessons and we'll be done. So here we go. All right, so this is just, we need to just work with exponents again. So if you remember, you actually have to multiply these 2 numbers together to get your answer. So 2 to the 12th power, 5 to the negative 10th, except we can't have negative exponents, so what should we do? We drop it down at the bottom. We don't want to actually do 2 to the 12th, 5 to the 10th. It's just a reminder of what you're supposed to do when you multiply. Also, one thing I did not teach was what 3 to the anything to the 0 power is 1. And I actually show why is that, so you're just going to have to take my word on it. But there is a quick proof that you can do, but I'm squeezed for time. So let's see. So then this is going to be 4 to the negative 8. And remember, if you have a negative exponent, you need to drop it to the bottom. All right. So that was just our exercise 1, just reviewing properties of the exponents. Now, exercise 2, what we're going to do is look at, well, you could have a fraction, an exponent that is a fraction. So what does that mean? So first of all, let's just go ahead and do what we would do. We would multiply that. So we all know 1/2 times 2 would equal 1. So since I equal 1, they basically cancel each other out. And so I get 16. So, and I don't like seeing that there, so I'm going to erase it. So far, that makes sense, right? So let's talk about really what the 16 1/2 really means. So let's ask ourselves a question. What other number to the 2nd power or squared also equals 16? Well, I hope you said 4. So 4 to the 2nd power also equals 16. When you look at that, that means that these 2 things right here, they must equal each other. They have to, because they both equal the exact same thing. So since they both equal each other, that means 4 equals 16 to the 1/2. You're like, 4 equals 16 to the 1/2? How is that possible? All right, well, let's keep going there. Again, 4 equals 16 to 1/2. Well, what could you do to 16 to get back to a 4? And I hope you said square root. So 4 equals 16 1/2, which also equals the square root of 16. Therefore, an exponent of 1/2 is equivalent to a square root of a number. It's another way to write it. And if you did it on your calculator, it would have, if you put 16 to the 1/2 power, it would give you 4 back. So another way to write a square root is to write it as a power of a half. So we're just going to practice answering problems or converting so we can think like that. So let's look at our examples. Before we start our examples though, please remember your perfect squares. I have attached all the squares on a PDF that you can get to on Schoology as a part of this lesson. So here, let's just keep going. All right, so 25 to the 1/2 power really means the square root of 25. Well, what's the square root of 25? 5. So when you see that 1/2, I need you to think square root. 81 to the 1/2, oh, that's the square root of 81, which is 9. Easy. Next one. 100 to the 1/2 equals, oh, that's the square root of 100. 10. Now the last one, which is important, 36 to the negative 1/2 equals, well, first let's get rid of the negative. So we're going to drop that in the denominator. So we got 1 over this 36 to the 1/2. Well, we know that that's 1 over the square root of 36. So therefore, this answer is 1 over 6. So D is probably the hardest, but if you can think about it without the negative, like you did all the other problems, then you could just say, oh, I could think about it like this. And then since I know it's negative, I can make it a fraction. So think about it like that. All right, so that was exercise 3. All right, now I want you guys to look at the numbers to the 3rd and 4th power. So I gave you, because we need that. So I gave you all the first 10 numbers to the 3rd power, natural numbers to the 10th power, and the first 5 numbers, natural numbers to the 4th power. All right, so a cube root is the inverse of a number to the 3rd power. So cube root versus square root. All right, so there is a such thing to do a cube root. And so what we do, how we change the type of root we want, is to put the little number here. Square root is like the base that we use. We're always used to square root, so it doesn't have to have a little 2 there. But if you wanted to put one there, you could. It's just that's the most common one used in mathematics. So we don't put the 2 there. We know when we see that it's a square root. But there are so many other roots, because if you can take something to any power, then you have to have a root to undo it. So here we go. So therefore, the cube root of 8, well, if I look here, 2 to the 3rd power is equal to 8. So therefore, to undo 8, the cube root of 8 is equal to 2. So let's just do a couple of make sure we understand. Well, what's the cube root of 125? Well, the cube root of 125 is 5, because 5 to the 3rd power is what gives you 125. And last but not least, the cube root of 1,000, we got that right there, is equal to 10. All right, now let's apply this to that same property that we just did. Oh, we have to do 4th powers. So you can have a 4th power. So let's look at the 4th power chart. So the 4th power, a 4th root of 81 will give you 3, because 3 to the 4th power is 81. And a 4th power of 625 is 5, because 5 to the 4th power gives you 625. All right, so now another thing that you also might want to remember is the powers of 2. Very important in computer science as well, because computers deal in binary. Now, here we go. So our rule is the unit fraction exponents. That means for n given as a positive integer, b1 over the n is the same as that. So anytime you see 1 over n or 1 over a number as an exponent, you can just write it as a root and think about it that way. That's how you can do your math. So here we go. So let's do 125 to the 1/3. So we don't want to think about it like that. What it really means is the cube root of 125. That means I need to be on this table over here. So what to the 3rd power gives me 125? 5. So then that's my answer. Let's go to 16 to the 1/4. So 16 to the 1/4, 16 to the 1/4, oh, right here, here's 16. So we want to rewrite it as the 4th root of 16. So therefore, that is 2, because 2 to the 4th power gives me 16. All right, so now let's do 9 to the negative 1/2. We do not want to work with the negative. So let's go ahead and rewrite it. We know that's going to be 1 over 9 to the positive 1/2. Well, that can be written as a square root. And so what's the square root of 9? 3. All right, so here we go. We got our last one, 32 to the negative 1/5. So I see 32 over here. So I know I'm probably is going to be my answer. So let's go ahead and get rid of the negative by dropping it down. Let's turn it to the root and then ask ourselves, what to the 5th power will give me 32? 2 to the 5th power will give me 32. The 2 has to go right there, and I get 1/2. All right, next part. Now, here's our last exercise. Let's look at fractional exponents that have a number in the numerator other than 1. So we're going to look at 16 3/2. So how can I think about that? Well, I can think about it this way. 1/2 times 3. That's what would give me 3/2, if you agree. So let's separate it out like that so we can think about it. So I know that the 2 at the bottom is a square root. So any number that's in the denominator is your root. And since square roots don't have to have a number right there, then I know it's the square root of 16. The 3 is actually your power. So you can just put that on the outside. So to do this problem without a calculator, you would say, oh, I need to do the square root of 16 and then take that answer to the 3rd power. So the square root of 16 is 4, and 4 to the 3rd power, we have it over here, is 64. Let's do another one. 27 to the 2/3. So let's start with this 3. So what does this 3 mean? That 3, because it's in the denominator of my exponent, it means it's a root. So I can write my problem like this. I need to figure out the 3rd root or the cube root of 27 and then take that answer to the 2nd power. Well, I see 27 right here, which means that 3 to the 3rd power gives me 27. So that means the cube root of 27 is 3. And now I have to take to the 2nd power, so that answer is 9. So now, here we go. It's telling you how you can write this. So when you see this, I would say don't write it like this. I would say write it like this. Because you would rather take the root first if you're evaluating, because it'll make the number smaller, especially if you don't have a calculator, and then you could take it to its power. So this, to me, is how I think about it. All right, here we go. So I have all our columns we need. I have our powers of 2, our x to the 3rd, x to the 4th. It's going to be helpful. So we have 16 to the 3/4 power. Well, how can I write that? What should be the root? The root should be the 4. So we have to do the 4th root of 16 and then take that answer to the 3rd power. That's how you separate it. So let's see if we can find the 4th root of 16. So here's x to the 4th, which is there. So that means 2 to the 4th power gives me 16. So therefore, the 4th root of 16 is 2. And then I just have to take it to the 3rd, so I get 8. So now you guys try that. Try to pause the video and then come back. All right, so here we go. We have 25 25 raised to the 3/2. So again, this is your root. So we have a square root, and then we got to take it to the 3rd power. Remember, you don't have to see the 2 because when it's by itself, we know it's square root. So then what's the square root of 25? 5. And then 5 to the 3rd power is 125. And then last but not least, 8 to the negative 2/3. All right, so first step, we can't have a negative. So let's go ahead and just move it to the bottom. Then let's do our rewriting. This right here is your cube root. 8, then take it to the 2nd power. The cube root of 8 is 2, and 2 to the 2nd power is 1/4. So there you go. That's this lesson. I know it's like 15 minutes, but the work that you have to do will go pretty fast. And I've probably done a lot of examples already that will be on the paper that you have to do. So again, just thank you for staying with the class and finish it out. And I appreciate you guys so much. I miss you guys. And I'm about to post your last lesson. So here we go. Thank you so much. Stay safe and be good. Bye.